Hi everyone, my name is Abdelak Ben Ali. I am a simulation and electromagnetics expert at Dassault Systèmes, and today I am going to discuss about the benefits of the 3DEXPERIENCE platform for a CST user. So this is the content of today's presentation. So first I'm going to introduce the 3DEXPERIENCE platform. Maybe some of you are not familiar with it, and I'm going to discuss about why it has been created and what's its purpose. The second topic I'm going to address is how can CST user can take advantage of the 3DEXPERIENCE platform. And finally, I will perform a demo directly on the platform to show you a use case example of a CST user using the platform to get first the 3D CAD models, second, simplify them, and finally, retrieving them back into CST. Now, let's assume that you are working in an automotive or industrial equipment company. And let's say you are on a project along with some of your colleagues. In this project, there are mechanical engineers to take care of all the simulations related to your product structure. There is also drive, battery, and electrical system engineer, and also a couple of other people working on the same project. The question is, how are all these people going to work and collaborate? Well, usually the answer is that they are probably going to work in silos, meaning that each and every one of them is going to work on his side with very limited interactions with the other. There are a lot of problems coming with this way of working. For example, integration issues, data loss, many iterations, long cycles. And generally, this is not a very efficient way of working. This is where the 3DEXPERIENCE comes in. The main purpose of the platform is to connect all these people together, enabling them to work on the same platform, same interface, and same models. This is really the key element behind the 3DEXPERIENCE platform. Now let's go back to our typical CST user. There are three different types of CST users. The first one is probably the most familiar for you. It's the user that has CST installed on his laptop or computer. He has a standalone license, and basically he uses CST locally to perform various electromagnetic simulations. The second type uses CST exactly like the first one, but in addition, he has linked his CST to the 3DEXPERIENCE platform via what we call a power by link. I'm going to go into more details of what this means practically afterwards. Finally, we have a third type, which uses the Dassault Systèmes cloud environment. And this part has already been addressed in a presentation before, so I am not going to really go into deep details about the cloud. So what are the benefits of the 3DEXPERIENCE platform for a CST user? Well, the answer is simple. It enables him to have a direct connection with all of the project stakeholders, going from the 3D designers, simulation engineers, to the project managers. In addition to that, he'll be able to leverage the power of the platform to perform some tasks that would not have been possible in CST. For example, the OE studies, the featuring, simplifications, and all other different tasks. This will be, at least a part of this will be addressed in the demo afterwards. This link actually enables a frictionless collaborations and communication. It also enables to have a single source of truth. It means that since everybody work on the same models, all the others are aware, or all the other users are aware of updates and adjustments in real time. ModSim also, which stands for modeling and simulation, is also key because it enables the designers and simulation engineers to work hand in hand on the same product. So now I will give just an example of one CST user that uses the platform, and it starts here with him installing CST on the platform on his local workstation. He's able to set up simulations and reviews full results in CST as usual. Now he used the Power by link to connect CST to the 3DEXPERIENCE platform. So this Power by link enables him first to save some CST Studio Suite files directly into the platform to share them with the others, but also he's able to load and retrieve various types of data from the platform. And since everybody else is working on this platform, he will also be able to perform various tasks. For example, manage and process CAD models directly in the platform and perform defeaturing tasks, simplification, etc. He is also able to load and view results of the other project stakeholders. And since everybody is sharing their results on the platform, everybody can see the results of everyone else. And finally, he can also get updated 3D CAD models in real time. And finally, he is also able to submit and run and monitor simulations on the cloud. And this is, for example, in the case where the user has a large model that he cannot run directly on his laptop, and he is able to leverage the Dassault System Cloud and use it for this type of big simulations. Finally, I'm going to do just after this a demo, and this is the content of the demo. Of course, I am going to work on this powertrain model, but it can be, of course, anything. It can be a car, it can be a plane, it can be any product. This is just of course, for the sake of the presentation. And we are going to start by opening the platform and looking for and opening the 3D model first, which is owned by the designers, of course. The second step is to select the appropriate applications. I'm going to explain, of course, the concept of applications in the platform after. On the third step, the user creates an abstraction shape or a copy of the parts that we are interested in. We are going to simplify on the fourth step these parts and retrieve them back to CST as a last step. So let's get started. Okay, so now I am in the 3DEXPERIENCE platform, and everybody working on the platform will have exactly the same interface as what you see here. In the top left, this is what we call the compass. When I click on it, you can see that I have a set of roles here, and each role gives you access to a set of applications. For example, if I click here on Electromagnetics engineer role, it gives me access to 2 applications. If I click on another role, it gives me access to a set of other applications. And of course, each person using the platform will have a different set of roles. Now, the concept of applications or apps that we have here is exactly the same that you have on your phone. Basically, each one or each app allows you to perform a specific task. And we're going to see during this demo how this works. On the right of the compass, you have the name of the applications that we are in right now. And here, for instance, it's called collaborative lifecycle applications. Basically, it's the application that helps you browse through your modules in the platform. Now, I can close the compass and I'm going to open the 3D CAD model that I need to work on. But before that, you need to understand that I am not the owner of this CAD. In fact, this CAD model belongs to another designer, and he's the one that generates it and can modify it using, of course, his predefined set of apps. So let's open the CAD model. So to do so, we can use the search bar that we have here. So I will just click on it and type drive, for example. I know that the name drive, the name of the 3D CAD model that I use contains this name. And now I have a set of results. As you can see, I have a lot of results. And these results actually are all the public data that are on the platform inside my company, of course. And as you can see, I have more than 40,000 results. So I will need to do more digging to find my file. And to do so, I will use here, this button here, which is called the 6W tags, which is basically a filter on these different results that I got. So now I will filter on the name of the person and the name of the designer that generated the CAD model. So I will type his name. It's Romain Jolet. I got it here. So I click on Romain Jolet. And now I have two results only. And I know that this one that you see here is the file that I was looking for. So I'm going to open it. I just right click. Okay, so now I have this 3D model that has been generated by the designer. Of course, I have access. I can visualize the model. I have access to all the different parts of this 3D model. So now what I want to do basically is that I want to just select a part of this powertrain model and import it to CST. Okay, so the part that I am interested in, let's say it's this part here. Of course, keep in mind that this is just an example. And this model can be a car, it can be a plane, it can be anything. For example, if you are a radar supplier or an OEM, an automotive manufacturer, you have a car and you are a radar, you want to do some integration, let's say integration simulations in CST for the radar, you would just pick a part of the car and import it in CST. You don't want to have the whole car in CST. And this is exactly what we're going to do here. So I will just open this small part in another tab. As you can see, I am on another tab. I just filtered the part that I am interested in. And now, as you can see, we are in the application CATIA assembly design. Okay, keep this in mind, because now what we want to do, of course, from here I can directly import this file into CST, but I will not do this for the moment. What I'm going to do is that I will try first to simplify this part and defeature. So simplifying and defeaturing is not always required, but for example, sometimes you have really complicated models, really complex models that have small features that are not really necessary from electromagnetic simulation point of view. So you want to get rid of these small parts because they will generate unnecessary meshes and they will really make your simulation really heavy. So this is what I'm going to do. But before that, keep in mind that remember that this CAD model is not owned by us, so we cannot really modify it. So what we are going to do right now is that we are going to create a copy of this CAD model. And to do so, I just click here on Derived Representations, Create New, Abstraction Shape. And abstraction shape in the platform is basically the same thing as creating a copy and working on it to do some modifications. So abstraction shape, and then I will choose the parts that I am interested in. So let me choose just this ones, the part that are here highlighted in green. I click OK. And now, as you can see, it has created the abstraction shape, the copy. And I'm going to work only on this part. So let us just rename for convenience the part that we just created, and I will call it, for example, simplified box. As simple as that. Okay. Now I forgot to add a D. All right. So let me open this abstraction shape alone because I don't need the rest right now. So I just right click on it and I open in a new app. And now if you remember, just before, if I go back, we were in CATIA Assembly Design app. And when I open the simplified box here, the abstraction shape that I just created, the platform automatically changed the app. And actually, Simulation Model Preparation app is the app that we need to do simplifications. And here what happened is that the platform understood directly that, I mean, it understands basically when you create an abstraction shape, it assumes that you are going to perform some simplification on this. And here you have an automatic process of application changing. Of course, you can do it manually. It does not always work like that. For example, if I want to change the application, this is really simple. I just click on the compass and click on part feature recognition. And as you can see, I can change the applications as simply as that to perform different tasks. Of course, this application, what are the differences? You may think, what are the differences between the applications? Well, basically, they just gives you access to a different set of buttons here on the bottom. So as you can see, when I will go back to simulation model preparation, the buttons that are here in the bottom just change. So now I am in the right application. I have the right to modify the model I'm in. So this is exactly what I'm going to do. So first, let me just focus on this part here. Of course, I can do everything once, but let me hide this one so that it can be clear for you. Okay, so I have this part here, and as you can see, it has some complexity on it. Of course, you can encounter some much more complex part than this, but we can notice that we have some holes here. Holes generally are not really important from an electromagnetics point of view, so I'm going to try to take them out. We have fillets here also that are not really necessary from an electromagnetic point of view, so I'm going to try and take them out. So I click here on the featuring, and now I will add some filters. For example, I will click here on hole filter plus, and then basically here what I'm telling him is that I want you to remove all the holes that are between 0 and 10 millimeters in diameter. This is what I'm asking him to do. I click OK. And as you can see, you have a new line that popped up. It's one of the filters that I just added. I will add a second filter, which is the fillet filter. And I will do exactly the same. I will ask him to remove, let's say, all the fillets between 0 and 5 millimeters in radius. Okay. And I have my second line here. And I click OK. Now, as you can see, all the holes that I had in my model here were taken off, and the fillets that I had here also disappeared. So this is a good start. This is a good start to my model. It's a good model, but I want to simplify it even more. So you see that I have a bit of complexity here on the top. So I will try to simplify it. I click on remove face and I will ask him to remove these faces. Okay, and here I click on the face that I want to keep. Okay, there is this face that I want to keep also, and this face. Okay, and now I will try to click OK. And now, as you can see, I really have a much more simple cover for my box. I can do the same thing on the other face. Okay, let's do the same. Okay, I want to remove this face, this one, like this, for example. And these are the faces that I want to keep. Okay. Okay, hopefully this will work. Okay, click OK, and this worked. As you can see, we have a really simple cover right now compared to what it was a few minutes ago. Let me remove this face also. Okay, can remove this feature also because it's not really necessary. Okay, so now I'm happy with my cover, with my simplifications, and I can do the same things with the other part, which is the one that I just hid. Sorry. Let me hide this cover, and now I will do exactly the same things. So I will apply some filters here. I will try to go fast because the process is the same that what we did before. Okay, the fillet. I click OK. Oh, sorry. Yeah, I need to click here, and then it should work. All right. Now, as you can see, I have a simplified model here. All the holes, the small holes have been suppressed. And let me just show the other part. And now I'm happy with this model. I am happy with this model and I want it to be imported in CST. So let us save. Now my job is finished in the platform. I don't have anything to add. So I will go now into CST and I will try to import this file. So let us go to CST. Of course, in CST you have this this window, the first window that pops up in CST. And here I have this button, 3DEXPERIENCE. And this is the one that I'm going to use to import data from the platform. So let me click on load. And then here is, you may recognize this, it's the same search bar that we had earlier. So I'm going to repeat exactly the same steps. I'm going to type drive and filter on the designer name. And then I have found my file. Okay, so I can select it here. And before clicking OK, I will go here to select shapes. Let me just make it bigger. So I click on select shapes. So now, as you can see, all the shapes of the powertrain model can be imported in CST. Of course, this is not my what I want to do. What I want to do is that I just want to import only the part that I just defeatured. So let me just unwrap this tree, and hopefully we will find the files that we were looking for. And in fact, I'm just seeing it. It's here. It's a simplified box. So this is the only one that I want to import. Of course, I can import also the not simplified models of the box. We can do that also. So I can click on this to see what's the difference between the two models. Now I click OK. Now it is asking me to save the model locally in CST. So let us define box. Okay, let me save it just here. And now it is downloading the geometry from the platform. As you can see, I have my model now in CST that I can see. Of course, since I imported the simplified and the non-simplified models, there is a bit of overlap here. So let me just first hide the simplified one before. As you can see, this is the model that has been uploaded by the designer, the original model. And now if I hide this and just show the simplified box, as you can see, I have my simplified box that is imported in CST with all the modifications that I did earlier. And from here, of course, we are in CST and we can do whatever we want for the simulations. So this is the end of my demo and presentation overall. Do not hesitate if you have any question to ask them, and I will be more than happy to answer them. Thank you very much.
Thanks. I would like to compliment a few things on this very nice demo from you, Abdelhak. So we've seen earlier already the potential usage of an existing CST user for or of the 3D Experience platform, that you have this holistic view on the product development with requirements, project management, and so on. So you've seen that it's about collaboration, single source of truth, communication, and modeling and simulation. And in more detail, I would like to highlight that it's across all geos and functions. The single source of truth does not limit to be for CAD data, and you can transparently communicate requirements, and that you can do ModSim, meaning integration of modeling and simulation, also with non-so-called native CAD data, meaning non-CATIA data, which I will show you in a few seconds. So first of all, let's have a look at the requirements. So as you see here, the requirements basically are edited in a web-based environment. So this is kind of a web-based version of the 3D Experience platform, which is quite easy to use here. And you see you can define the requirements from very high level, meaning just a very brief description on what you would like to achieve, but you can go more and more into details and finally define really values of your electromagnetic properties, for example, the insertion loss here. And then you can also see who's the owner of the requirement, and you can also see if the requirement is up to date or not, because requirements are living objects which can be life cycled as well. You can see here also the return loss, and the same as well. You can have very detailed requirement values, which then can be used also later on to judge if your simulation result is valid or not, because these values which you enter here, we will connect later on to the simulation result. So that's the, let's say, the start of every development process, the requirements. But of course, thinking about that 40% of the product development cost go into tests and verification. Testing is actually quite an important part of your development. Therefore, if you can optimize that part, you also save some time and cost. And here you see on the right an app, which is the verification strategy app, where you can define so-called test cases and test executions. In principle, you could also assign some scripts where you tell your workers on how they should test or how they should simulate something. And also here, the concept of single source of truth is very important. You see, for example, in the test case, that you can specify, first of all, what's the item under test. So you can directly assign your CAD data to your testing. That means you don't have these exporting and importing. You can assign also a person who's supposed to do it. And then once you have performed the test, the same holds as well. So here you have the pass test. And here you can directly hand over the simulation results. So once somebody has to approve this test, he can directly see the simulation results and approve it accordingly. You see also that the test cases also have lifecycle management. So everything is kind of living in the platform. And then what's maybe most interesting is that you can have a very nice matrix overview here, where you see if a requirement is tested. So you see requirements versus test, and if a requirement is tested or if some requirement is missed, so that you can make sure you test all the requirements needed, but not too much. The next thing I said is modeling and simulation are very tied together. And we know that many of our customers do not have, for example, especially in high tech, not CATIA, but you have here a SolidWorks structure, but still the same. You can still work data-driven and model-based via the 3D Experience platform so that you avoid error-prone importing and exporting. So here, for example, we see a structure of the USB connector, which is open in its native CAD or in its original CAD data. And it's directly connected to the 3D Experience platform, where you can see here the attributes. And also you can see the relations of the different objects on the platform. That often is also quite nice. You can open the model directly in, as we've seen earlier, in connector for CST or the CST connector, depending on if you have COC or the platform. And then you can set up your model as you're used to. You set up ports, etc. And you can verify that everything is ready to be simulated. And then you can basically upload this or connect it to the 3DEXPERIENCE platform. And you save now the simulation object to the 3DEXPERIENCE platform. And by that, you have direct continuity between the CAD model and the simulation. And that becomes important once you perform a change. For example, we have now, by an initial simulation, found out that we need to shorten some of these pins of the USB connector. Then we can go back to its original CAD file and change, for example, the value of a formula here, or just the value of some connectors pins. So we see that some of these pins are shorter than the others. And you see also that the status is that it's out of date, but we can save it as a new version, as an improved connector version, and save it on the 3DEXPERIENCE platform. Now, this is a tricky part, which we should stop here. So you see that you can, in the simulation you've set up earlier, you can ask for a CAD update. So you can ask to check if anything is new. So you haven't changed your simulation file before, so far, and you just check if you have a CAD update. And then it notices that something is out of date. And you can directly re-import this without having to change any settings. So the ports are there and so on. And then, of course, you can re-simulate it. And once done, you can also save this one to the 3DEXPERIENCE platform. Of course, you can before also check that it's the correct model. And save this new version of the simulation to the 3DEXPERIENCE platform. So that means you get notified when you have an update or your CAD data, and you're always working on the latest model. So you don't have these exchange and or export and import issues. And I know typically we have tons of files on our hard disk, and you don't know after a while anymore, is it now version 7 or was it 7.1? So you're always working on the latest version. So now we have uploaded actually the file on the platform, and I would like to show you a little bit on how it looks like and what different objects you have on the platform. And we also see how to connect the results to the requirements. So let's open the 3DEXPERIENCE platform here again. So I'm searching for my connector files. So I'm searching basically for everything which is called connector. And you can also, of course, change if you want to sort for relevancy or for latest. So I typically like to sort for latest. And here I would like to show you what you actually see. So the ones with the gear wheels are simulation objects. These are basically CST files. Then you have these kind of bricky things. This is the CAD data, which has been generated before by SolidWorks, by CATIA, whatever. These things here we will generate later. So this is actually up to come. And I see basically here all the connectors which are required to my name. And yeah, this is very nice because in principle, I can share this data with whoever has access to the cloud, meaning I can share it across functions and I can share it across geos. So for example, I had to work with a colleague who is based in the West Coast of US, but I don't have to wait for him to come to work before I can start my simulation because it's on the platform and I can just take it from there and search for it. So let's continue. So you see here I have my 2 simulation runs. I have also the option to revise some things. You see here, these are my files. And then I can have a look on the simulation results on the platform. We can also, this is maybe also kind of interesting, you can also tag for lots of things, or you can search for many things, which is really nice, especially if you have to find your specific file in a quite big amount of data. So you can see I can search for the geolocation, I can search for a collapse space. But you have also some more tags like the type. So am I searching for a CST file or for whatever SolidWorks or Creo file? So all this is possible and makes, let's say, life much easier than on a file-based system. So let's now compare the two results. I do this in a, you see here, this was just a generation of a web-based so-called widget. So basically I take an app and plug and play it or plug it to the dashboard here. And this app can compare different simulation results. So I will now search for the two connector simulations, which we have generated before. So again, I search for connector and my name, and I see the two results. And then I open it, and now I'm creating a so-called analytics case. It's basically a comparison case between two simulation results. And this sets up a table, which then looks like that. And of course, maybe it's not such a wow effect if we just have two results. But if you imagine you can do the same with more or less the same number of clicks, even if you have 10 results, then it can be quite nice to get an overview on which one is the best. So you see here in this column, we have a requirements column. And here I could in principle manually say what should be the target. But I can connect it to the requirements which we have introduced earlier. So I can now search for the requirements, which were actually generated by my colleague, David. And I search for them. So they are in a different collapse space. And once I have them, you see the requirements for the return loss and the insertion loss, which we introduced at the beginning. You see, I can directly connect them to my simulation results. And by the way, here it's maybe interesting, the KPIs, which are shown in the table already, are basically result templates, which you know from CST. So you can kind of have every KPI you want. So now I can say, I connect them to the requirements. And as soon as I do so, I have the targets available. And now you see quite nicely which one is the best. So as said, if you just have two, it maybe is easy to do with just by looking at it. But if you have maybe 10 or more, then it can be a bit more complicated. You see also directly if a requirement is violated, then you have these little exclamation marks, and you can also see what the requirements are actually specified. And then if you like one example, you can, as shown earlier by Hilary, you can already view it in this web environment. And you can check, for example, the sensors, or meaning the results in 1D, or also you can choose the 3D results, which are in a light manner, so you can also view them on a phone. And maybe this is important. So in principle, you can here share the results with stakeholders of your project, which might not be simulation experts and who also do not have to have the software installed. Okay, and then you can potentially decide which one is the best, or if you see any other issues, and then maybe you like your simulation results. And then one last feature, which I would like to show you because I think it's a kind of cool inbuilt functionality of the 3DEXPERIENCE platform, is the so-called relational explorer. So in principle, the platform always knows who relates to who. And you've seen earlier that I've created this so-called analytics case, which was basically the comparison of the simulations. So if I, for example, look for it, you see here all the different types of objects I can look for. Obviously, I have lots of stuff on the 3DEXPERIENCE platform. So I now look for my analytics case of the connector comparison. And I can say, okay, what are the relations? And then you see here the object, the analytics case, the comparison, and I can then click on what are children and parents, and you see that it relates to the requirement and that it's actually loading the two simulation results. So you typically get a very nice overview what actually is connected. And with that, I hope you had some fun and learned something new. And I'm finished with my presentation.
Okay, thank you, Monica. So sorry. Okay, so we have a few questions. So just before leaving, I think we have quite a few questions. So if you cannot answer, so we'll answer you then afterwards offline. For Abdullah, so what's the advantage of using the abstraction shape and not just you do a normal copy? I mean, you can make a copy of the links that you made. Yeah.
Yeah. So actually, the abstraction shape is not exactly like. Yeah. Do you hear me? Oh, yeah. Yeah. Like I said, the abstraction shape, in addition to being a copy, it's also linked to the original geometry, so that when there is a change in the geometry by the designer, it directly applies to the abstraction shape, and you always get the updated version of your CAD, like what Monica just showed. You always get the updates, even if there are changes. This is the difference between the abstraction shape and just a simple copy.
Okay, thank you. We have a couple of questions for you, Monica. So, well, maybe from the last one. So you have shown at the end that we can find out what requirement is connected to the to which simulation. Does it work for all the objects? So can we see also connection between simulation and PCB or electronic data, which I mentioned before?
Yep, you can see also the connections between the simulation or a physical product on the platform, even if it's coming from, for example, Cadence or Altium. So in principle, it is not limited to the simulation and the requirements. You can see connections between all kinds of objects, as long as they're connected, of course.
Okay, last question. What about, can the test strategy automatically run simulation as well?
No, sorry, that is not possible. I think that actually would be a very cool thing to do, but currently it's basically to keep an overview. So you have always the latest simulation to your, you can assign it to the test case which has been, or test execution which has passed. You can assign also scripts, but it does not automatically run a simulation.
Okay, thank you, Monica. Thank you, Abdullah. Thank you, Avinda. Thank you, everyone, for attending this session. We are finished today. I wish you tomorrow another exciting day with electromagnetics. We'll talk about electromagnetic compatibility. Thank you very much for your attention, and talk to you soon. Bye.